Okay, so here, so in engineering hydrology, runoff due to a storm event is often a measure of subject of the body. All abstraction from the precipitation that is due to evaporation, transpiration, infiltration, surface detention, and storage are considered as losses in the production of runoff. Chief components of abstraction from precipitation, knowledge of which are necessary in analysis of various hydrological situations. So previous chapter it is divided. So evaporation. So evaporation. Let me annotate first. Annotate. So, yes, evaporation from the water bodies and soil masses together is called transpiration. Okay, and it is termed as evapotranspiration. So evaporation process. How evaporation takes place? Evaporation is a process in which a liquid changes to gaseous states, isn't it? At a free surface below the boiling point through the transfer of heat energy. So if you consider a body of water in a pond, the molecules in water are in constant motion with a wide range of instantaneous velocity. Okay. So evaporation is a cooling process. Okay. Evaporation is a cooling process in that the latent heat of evaporation must be provided in the water body. So the rate of evaporation can it is depend on the rate of evaporation is depend on the vapor pressure, the water surface and air and water temperatures, wind speed, the atmospheric pressure, quality of water, size of water body, etc. So the rate of evaporation is depend on the vapor pressure. So what is vapor pressure? The rate of evaporation is proportional to the difference between the saturation vapor process in the water temperature and the actual vapor pressure in the air. That is EL equal to CEW minus EA. And where EL is the rate of evaporation and C is a constant, rate of evaporation and C is a constant, EW and EA are in mm of mercury. So equation 3 is not known as Dalton's law of evaporation after John Dalton. Okay. So temperature, other factors remaining the same, the rate of evaporation increases with increase in water temperature. Regarding the air temperature, although there is a general increase in the evaporation rate, with increasing temperature a high correction between evaporation rate and air temperature does not exist. Thus, for the same mean monthly temperature, it is possible to have a evaporation to different degrees in a lake of different months. And next is wind speed. So wind speed winds aids in removing the evaporated water vapor from the zone. So if there is a more speed of wind, there will be more the rate of evaporation, okay? Atmospheric pressure. Other factor remaining the same, a decrease in barometric pressure as in high altitude increases evaporation. So in high altitude, there is a higher degree of evaporation. Okay? And soluble salts. When a solute is dissolved in water, the vapor pressure of the solution is less than the pure water and hence causes reduction in the rate of vapor pressure. So if there is a there are soluble salts, so there will be less rate of evaporation. Okay. There will be less rate of evaporation. Next, heat storage in water bodies. Deep water bodies have more heat storage than shallow ones. A deep lake may store radiation energy received in summer and released in winter, causing less evaporation in summer and more evaporation. Okay? So there are some instruments which can measure the evaporation rate. Okay? These are called evaporimeters. Evaporimeters. Estimation of evaporation is the important part in hydrology. Okay. So in arid regions, this estimation is particularly important to conserve the scarcity of water resource. However, the exact measurement of evaporation from a large water body indeed one of the most difficult tasks. The amount of water evaporated from a water surface is estimated by the following methods. So, what are by using evaporimeter data, empirical evaporation equation, and analytical method. Okay, and types of evaporimeters. Evaporimeters are water-containing pans which are exposed to the atmosphere and the loss of water by evaporation measured in them in regular intervals. Okay, so these are generally water containing pans. Such as humidity, wind movement, air, water temperature, and precipitation are also noted along with evaporation measurement. So here is in the figure, there is a class A evaporation pan. Okay, here is a class A evaporation pan. It is a standard pan of 1210 mm diameter and 255 mm depth used by US Weather Bureau. Okay, and this is known as class A evaporation pan. So the pan is normally made up of unpainted galvanized iron sheet. Monel metal is used where corrosion is a problem. The pan is placed at a wooden platform of 15 centimeters. So this plane is placed at wooden platform. Okay, at 15 centimeter height above the ground to allow free circulation of air below the pan. So there is a gap between the base of the pan and ground. Okay, 15 centimeter height. Evaporation measurements are made by measuring the depth of water with a hook gauge in a sealing well. So this is the water level. So first of all, water level are measured. After evaporation, how much is left at certain interval of time that is measured. So suppose initially it has losses is 50. So 50 will be an evaporation. Okay. Next pen is designed by Indian Standard Institution and that is IS. ISI standard pan. The pan evaporimeter specified by IS 5973 1970 is also known as a modified class A pan. Modified class A pan consists of a pan of 1220 mm in diameter and 255 mm of the depth. The pen is made up of copper shade of 0.99 thickness and tin inside and painted outside. Okay. So the top of the pen is covered fully with a hexagonal wire netting of galvanized iron to protect the water in the pen from birds. So in the surface of the pen, after any water, it is protected from the to protect from the bird. It iron a net is provided. Okay. Further, the presence of wire mass makes the water temperature more uniform during the day and night. The evaporation from this pan is found to be less by 14% compared to that from unscreened pan. The pan is placed over a square wooden platform, a 1225 mm with 100 mm height to enable circulation of air underneath the pan. So there in the figure that is the system of ISI evaporation pan. So basically this pan is designed by Indian Standard 5970 1970. Okay. There is a copper sheet. Thickness is 0.99. This is the wooden platform. And this is the thermometer clamp. Thermometer is placed in the water to measure the temperature. There is a fixed gauge. And within the gauge, you can directly measure the loss of water. So that is your evaporation, isn't it? Have you understood how evaporation is measured using a pen? Okay. Next, there are another pen, colored sunken pen. This pen is 920 mm square and 460 mm deep. Is made up of unpainted galvanized iron sheet and buried into the groundwater within 100 mm of the top. The chief advantage of the sunken pen is that the radiation and aerodynamic clear characteristics are similar to those of a lake. However, it has the following difficulty. Difficult to detect leaks. Extra care is needed to keep the surrounding area free from tall grass, dust, etc. and expensive to install. Okay. Next instrument is, so this is the Colorado sunken pan. This is the US Geological Survey floating pan, and there are pan coefficients CP. Evaporation pans are not exact models of large reservoir and have the following principal drawbacks. So what are the drawbacks of these pans? They differ in the heat storing capacity and heat transfer from the sides of the bottom. The sunken pan and floating pan aim to reduce this deficiency. As a result of this factor, the evaporation from a pan depends to a certain extent of its size. So generally evaporation is depends on the size of the pan. While a pan of 3 mm diameter is known to give a value which is about the same as from a neighboring large lakes. A pan of size 1.0 meter diameter indicates about 20% excess evaporation than the 3 mm diameter pan. 3-meter diameter pan, okay? And the height of the rim of an evaporation pan affects. So, uh, although we used pan to find out the evaporation rate, there are some difficulties. because the evaporation rate is difficult for that is different. Evaporation rate is different from dif- different size of the pan and height of the rim, the heat transfer from the premise material, and also it is depends on the transfer characteristics and pan material. Okay, so in the view of the above, the evaporation observed from a pan has to be corrected to get the evaporation from a lake under similar climate and exposure condition. Thus, a coefficient is introduced as lake evaporation equal to Cp into pan evaporation. Okay, where Cp is the pan coefficient and the values of Cp is different from different material. These are the different Cp values for different classes of. There are different pan coefficient for different pan. Class A plan average value is these. The average values ISA pan, Colorado pan, and USGS floating pan. Okay. Next, evaporation stations. So where you can place the evaporation pans, where from there are some stations. It is usual to install evaporation pans in such location where other meteorological data are also simultaneously collected. The WMO recommends the minimum network of evaporimeter station as below. Arid zone, one station for every 30,000 kilometers square. Humid temperature climates, one station for every 50,000 kilometers square, and cold region, one station for every 1 lakh kilometers square. Currently, about 220 pan evaporimeter stations are being maintained by. Currently, there are 220 pan evaporimeter stations are being maintained by India Meteorological Department. Okay, a typical meteorological station contains the following: ordinary rain gauge, recording rain gauge, Stephen and box with minimum 9. Okay, so you can buy this book from Flipkart and Amazon also. Okay, very good book for hydrology. And there are some empirical evaporation equation also. Empirical evaporation equations. One is your Mayer's formula, Rohr's formula. Okay. Okay, next class we will continue. How many students are there? 27, 28. And write your enrollment IDs. In, all of you write your enrollment IDs. Chat box. Write your enrollment IDs here. Okay, so I don't know about whether your classes will be taken online or offline. Now, they have we have not noticed. Okay, we have not get any notice related to offline classes. Whenever we'll get, we'll inform you. Okay. Okay. Thank you.